All right, now that we know what acids and bases are, now we can start writing equations as to how they're going to react together. The easiest way to write these equations is to remember what we learned back in chapter 6 when you learned how to predict the products for a double displacement reaction. And in a double displacement reaction, I believe what I told you then was that it's almost like you've got two couples who are dancing on a dance floor and they're just going to swap partners. Okay, so that's what we're going to think of when we're writing the products for these acid-base reactions. I did put these on your sheet for sample problems for video number 4. So if you want to pull that out and look at it. The first one we're going to look at here is HNO3, which is nitric acid, plus AlOH3, which is aluminum hydroxide. Hopefully you still remember the names of all these different polyatomic ions and their charges, because that's, again, it's going to, as I told you, it's going to be coming back all the way through the rest of the course. So what are the positive ions? Well, the hydrogen is the positive ion here, and the aluminum is the positive ion here. So these guys are just going to swap places. Okay, so that means that the aluminum is now going to pair with the negatively charged nitrate over here. So the aluminum will pair with the nitrate. Now I have to make sure that my charges are balanced. If you look on the periodic table, aluminum is in the column where it will have a positive 3 charge. The nitrate ion you should have memorized has a -1 charge. So in order to have this compound balanced, I will need 3 nitrate ions. Okay, that leaves me with this hydrogen ion going with this hydroxide ion. And so if I wrote it strictly as an ionic compound, it would be HOH, a hydrogen ion and a hydroxide ion together. But when we look at that, we really know that all that is, HOH is just the same as water. And so typically we write it as H2O. Okay, so again, when you balance this, the easiest thing to do is to look for the groups of ions. So in place of like counting up all the oxygens and counting up all the hydrogens, look for the groups and where those groups have moved to, and it's much easier to balance that way. So let's start with the aluminum. The aluminum is already balanced on each side. I have 3 nitrate groups here, and so I will need 3 nitrate groups on this side. If I look here I've got 3 hydrogens and 3 hydroxides. So what that means is that I'll need 3 waters on this side to make it balance. Okay. The second equation we'll look at here is H3PO4, phosphoric acid, plus MgOH2, which is magnesium hydroxide. So again, what we're going to do is we're going to swap the partners, positive for positive. So here your hydrogen ions are positive, here your magnesium ions are positive. So they are going to swap places. So what that means then is that my Mg is going to pair up with my PO4, okay? And you've got to balance your charges. Magnesium is in the second column on the periodic table, so it has a +2. You should have memorized that PO4 phosphate ion has a -3. So in order to balance that, I'm going to have 3 magnesiums and 2 phosphates, okay? Then I'm going to put this hydrogen ion with this hydroxide ion, HOH, or as water. And you'll notice that an acid and a base always make another compound and water, and this is commonly called a salt just because it has a positive ion and a negative ion with it. I know normally we think of NaCl as table salt, but these are similarly metal ions plus plus a non-metal or a polyatomic ion with it. So both of these things are called salts as well. So an acid and a base always yields a salt and water. Okay, so now that I have these 2 compounds written, now I need to go back and balance it. I have 3 magnesiums here, so I'll need 3 over here. I have 2 phosphate groups on this side, so I'll need 2 phosphate groups on this side. I have 6 hydrogen ions here, and I have 6 hydroxide ions here, so that means I'll need a total of 6 waters on this side, okay? So I don't anticipate that you'll have too much trouble with this. Again, you're just balancing double displacement reactions like you already learned how to do back in Module 6. So it shouldn't be too much of a problem for you.